Let's make some progress on our lecture number 4 about recursion. And last week I started talking about this lecture by giving you the resources to really catch up with the basic recursion in Java. Let me just go over them very quickly, and then we have to move on to the more intermediate examples. As I said, I just cannot really cover the basic recursion from scratch in this course. You will actually have to catch up with the basics and reach out to me if you got any questions, right? I can only wait for your questions, but I just cannot repeat all the basic details from in this course. All right, let's take a look. So we talk about a basic recursion. So these are the checklist of questions to make sure if you're feeling comfortable about basics. If you have any doubts about any of the checklist questions, in that case, go on to my earlier lecture for the prerequisite course, EECS2011. And it's the entire week over there, maybe about up to 3 hours to really catch up with the basics. That's definitely the time that'll be worth for you to spend catching up. And also for the tips, you can look over the slides to see if there's any part of the example you want to look at, maybe just watch for the corresponding video clips. I'll leave that decision to you, right? Whatever that works the best for you. And so there is one recursion lab from the earlier instance of EECS2011, and you can definitely look at the starter projects and also look at the solution, right? Just for your self-study. And ask me questions if you got any question about the recursion. The basics. And for this week, we'll start talking about the more intermediate example. So I may not be able to actually repeat every basic details or knowledge about recursion. So we're gonna just focus more on the design for the recursive algorithm itself. I'll do some tracing, I'll do some high-level description of the idea, and then I need to talk about the running time for the recursion, which is quite important for us to learn about how to derive the running time for recursive algorithm in this course. And one more mention about the extra challenging recursion problems which we did earlier in the semester in the Q&A section. We definitely talk about it, but if you miss those sessions there, it's really to your advantage. They have all been recorded. Right, so we got 1, 2, 3, 4. We got 4 problems over here. I would say once you catch up with the basics, did the 419 lab exercises on recursion, and also do the extra problems over here, I'm sure you will feel much more comfortable and confident about recursion. All right, that's something I'll rely on you to really do. And reach out to me if you got any questions. Alrighty, let's now move on to about the learning outcomes for this recursion lecture. Right, it's not really to cover things from scratch, so that's why I gave you the resources about the basics. And we're gonna learn about more of the intermediate recursive algorithm, especially we want to see how to do searching and sorting. And then if time permits, I will try to talk about another interesting classic problem that can be solved by recursion. So we're going to talk about binary search, and we'll talk about 2 sorting algorithm, merge sort and quick sort. And something I kind of mentioned to you in the beginning of the semester, every computer science or software engineering graduates should really know about at least 5 different sorting algorithms, at least 5. We already learned about insertion sort, selection sort, but they are not exactly that efficient. It's like n squared. And we're going to learn about this week for merge sort, quick sort, and later on we got another one to learn about, which is called heap sort, using some particular data structure called a balanced binary search tree. That's something we'll talk about later. So by the end of the course, you will be able to learn about at least 5 sorting algorithms. There might be other sorting algorithms. You can definitely reach out to other resources beyond this course, but at least you know about the basic 5s. I think every graduate should know. Good for you. All right. And if time permits, I'm going to talk about this problem over here. I believe many of you may have learned about this particular problem, Tower of Hanoi, maybe in your earlier math course. But I will actually suggest we actually talk about it and see how we can implement it recursively in Java. That's something I'd like to do. And you can we definitely want to explore some extra challenging recursive problems. Whenever possible, I'll try to bring extra problems to the Q&A, but definitely you want to at least go over these 4 that we did earlier in the Q&A. I think each one of them definitely cover like a different type of the recursive algorithm you can write, either on the array or be on the array list, or it's either mutator versus accessor recursive helper method, right? You definitely want to go over them and reach out to me as ever. Alrighty, so let's now go on to talk about this first recursive problem, which is about binary search.